let's now dive into a little more depth into what YOLO is, understanding what YOLO is. So as we said earlier, the start of the process is in dividing an image into different grids. For simplicity, let's assume that let's the number of grids be 4. So here we have divided the image into 4 different 4 into 4 grids. So we have total of 16 grids here. Now each of these grids will in turn predict two anchor boxes, or will have 2 anchor boxes. Now these anchor boxes are determined based on the number of images which are or objects which are likely to be there in that image within each of those grids. For our case, let's assume B to be 2. Now B can be any number, say 5 or 9, or depending on number of objects which are likely to be there in each of these grids. So let's take this central box, this specific box for our case, and let's assume it is predicting 2 different boxes like this. So it has detected, now the blue indicates a detection of potholes, and then the green indicates a car. So this is our base grid which we are considering. The only consideration which needs to be taken is the center of this each of this box will have to be in that specific grid. So if you can see, the center of this blue box is within this cell, and for this box also which has been predicted, the center is here in this grid. So that's about this B bounding boxes. Now this process continues for every different grids within the image. So you can see every image or every grid within the image kind of predicts 2 different bounding boxes. So some cases you predominantly have potholes detected, and you have only one car which is there. So according to which grid these objects fall in, you have that kind of the predictions of those boxes. And you can see the color of also this. The car is with a green color, and the potholes are with blue color. So now we have an image with multiple boxes, and the next step is to do what you call as a class probability maps. So a class probability map is something like this. So you mark or demarcate those area where there is one class, and demarcate the area with the other class. So here wherever the car is likely to be there is being demarcated with the green color, and wherever the potholes are there is been demarcated with a blue color. So these are called the probability maps. And the next step of the process is to apply non-maxima suppression. We saw non-maxima suppression in when we discussed about RCNN. So non-maximum suppression, as we know, is to reduce the number of boxes and to fuse together many of those multiple bounding boxes which we predicted, and to form one single box. So we have applied non-maximum suppressions, and we've got just 3 different boxes where there are likely to be objects. So here one within this green bounding box we have the car detected, and the blue bounding box we have the potholes detected. So after non-maxima suppressions, we get into the final predictions. So the predictions as we have seen earlier is in this format. So we have initially 5 different scores like this. The first of these score is a probability score. Now this probability score indicates whether there is an object or not. So if there is an object, this probability score will be closer to 1, and if there is no object, the probability score will be closer to 0. The other 4 are the coordinates of the bounding boxes. So here let's take this as the bounding boxes. This is the bounding boxes, and the first two, that bx and by, are the coordinates of the center of the bounding box, and then bw is the width of the bounding box, and bh is the height of the bounding box. So these are our 5 different of our predictions. And the last one is the class of the object. Now here class is not just a number. Class is in a one hot encoded format. So let's say, for example, we have 5 or 10 different classes. Okay, there are 10 different classes in this. So here the class would be we'll have 10 different boxes, which indicates the probability of what object is being detected here. So let's say, for example, so in this case we are determining there is a car here, and let's say, for example, car is of class 2. So in our example, so if the detection is correct, so class the second bounding box or the second class box, these boxes would indicate a number very close to 1. So I'm not saying if it is 1, it's exact. The detection is kind of 100% accurate, but we might not get that kind of detection. So let's say we get a probability of, say, 0.89 or 89%. Indicates 0.89 is the second box, which indicates a car, and the other bounding boxes or other class boxes will have some very low scores. So this is so these are the 5 different types of predictions which happen in each anchor box. Now imagine now you'll have to remember that each of these happens for one anchor box, and as we have seen, there could be number of anchor boxes for each of these cells like this. So each cell will have different B anchor boxes. So B could be, say, 5 or 2. In our example, we have taken as 2 anchor boxes for each grid. So you will have 2 different anchor boxes, and each of these anchor boxes will have these many number of predictions. So this is all about YOLO from a theoretical perspective, and we will see YOLO in detail in action. Now, YOLO, as I said earlier, YOLO is a very popular object detection algorithms, for the simple reason that it is pretty fast. You have just one forward pass wherein you predict everything. You predict the class and you predict all those bounding boxes. And since it is fast, it is used widely in real-time object detections. YOLO in its standard form, you get predefined or pre-trained models of YOLO 5, etc. All these pre-trained models comes with those standard set of objects which it can detect. So there are some standard sets of objects which it can detect, and that is what it will predict with a standard implementation. But our case, we have a very custom object which we want to detect, which is potholes. So obviously pothole is not in that standard implementation. Things like your car and your sign boxes, all these things are there as part of your standard implementations. So what we will do is we'll do a training of these YOLO from ground up. So we have to we will have our own set of classes which we want to predict, which includes our pothole also, and then we will train YOLO from scratch. Not from scratch. We will take a pre-trained model, a YOLO model, and then train it for the custom classes like your pothole which we want to detect. And that's what we will see in the subsequent videos.